A coffee pot has the shape of a cylinder with radius 5 inches, as shown above. Let h be the depth of the coffee in the pot, also measured in inches, where h is a function of time t, measured in seconds. The volume V of coffee in the pot is changing at the rate of negative 5 pi root h cubic inches per second. Show that dH dt, the rate of change of the height with respect to time, is negative root h over 5. Well, let's take an inventory of all the things that we have been given. We've been given the radius of our cylinder. Now keep in mind that the radius of a cylinder is constant. It's the same all the way throughout the cylinder. H is the depth of coffee in the pot, and that's measured in inches. Now the volume is changing at the rate of negative 5 pi root h. That means that the rate of change dV dt of volume is equal to negative 5 pi root h. We need to create a model that has both the volume of our cylinder as well as the radius of our cylinder. Well, they've given us what the volume of a cylinder with radius r and height h is. It's V equals pi r squared h. Well, let's just do this. Let's see what happens. Let's take the derivative of V. The derivative of V is dV dt because it's with respect to time t. We can pull out the pi using constant rule, and now we've got product rule on r squared and h. The derivative of r squared, remember, r is a function of time t. H is also a function of time t. Therefore, r is stuff and h is also stuff. We have to use chain rule here. The derivative of stuff squared is 2 stuff times the derivative of the stuff, of course with respect to t, times the second, plus the first, which is r squared, times the derivative of the second. The derivative of h with respect to t is dH dt. Alright, now let's think about this for a second. R is not changing. R is constant in this particular problem. It's always wise to locate what your constants are and what your variables are. The height of the water is decreasing as the water leaves this pot. However, the radius is always going to remain the same. The volume is also changing, so our two variables are height and the volume of our coffee. The constant is r. And of course, what's the derivative of a constant? Well, the derivative of a constant 5 is just 0. Look, we have a dr dt in here. Dr dt, the derivative of r, a constant, which is 5, is just 0. And 0 times anything is 0, so this whole part goes away. So now we have dV dt is equal to pi r squared dH dt. They gave us r is 5. They gave us dV dt is negative 5 pi root h. All we have to do now is solve for dH dt, which is exactly what they want us to do. They want us to show that dH dt is equal to negative root h over 5. So let's plug in all of our stuff right now. dV dt is negative 5 pi root h. We can plug 5 into r because that's our constant, so r squared is 25, and this is dH dt. If we solve for dH dt, we can just divide everything by 25 pi, and we wind up with negative 5 pi root h over 25 pi. The pi's cancel out. Bam, bam. Negative 5 over 25, that's negative 1 over 5, and so our answer is negative root h over 5. And of course, that's exactly what they wanted us to show. Now, there is an easier way that we could have done this. And this method requires that you are able to isolate your constants from your variables. For example, take a look at our model. Our model here is the model for the volume of a cylinder. There are three letters that we have to plug in at some point: V, R, and H. V is a variable because the volume of the cylinder is decreasing over time. So V is changing, making it a variable. H is also changing. The height of our coffee is decreasing over time, and because H is changing, H is a variable. However, R is not a variable. R is a constant. It's 5. It's not changing. It remains constant throughout the entire problem. No matter what happens to the coffee level, the radius is always going to be the same for a right cylinder like we have here. So for any constant that you have, you could just plug in the constant into R, yielding V is equal to 5 squared is 25 pi H. And this makes your derivative much easier to accomplish. The derivative of V with respect to t is dv dt. 25 pi is a constant, we can pull that out, 25 pi. And the derivative of h with respect to t is dh dt. At this point, all I have to do is just plug in dv dt, and you're golden. dv dt is negative 5 pi root h. This is equal to 25 pi dh dt. And when you divide everything by 25 pi, dh dt becomes negative 5 over 25 is negative 1 over 5. Pi over pi cancels out, and we have the root h on top. You get the exact same answer. So, either you could take the derivative of everything and realize that dr dt is 0 because r is a constant, or in the very beginning of the problem you could plug in your constant r and then take the derivative from there. It does simplify matters a great deal.